Well, hey everybody, Mr. E's back with you, and in this video we're gonna be looking at graphing vertical and horizontal lines. But before we do that, let's take a quick review of two different forms of equations that we've looked at. First of all, slope-intercept form, y equals mx plus b. So if, say I had the equation y equals 3x plus 2, right? When we graph it that way, we'd have our y-intercept of 2 right there. Remember, for every y-intercept, x equals 0, so you can see that point is 0, 2. And then we have a slope of 3, so it goes up 1, 2, 3 over 1, up 1, 2, 3 over 1, and so on. All right, so that is one equation in slope-intercept form. Let's go ahead and do another equation in slope-intercept form. Y equals negative 1/2 x, how about minus 4? All right, so that one, again, in slope-intercept form, you could see that the y-intercept is down there at negative 4, right? For every y-intercept, x equals 0. And then we have a slope of negative 1/2, down 1 over 2, down 1 over 2, down 1 over 2. All right, so those are slope-intercept form. That's the most common form we use when graphing equations. But we also have standard form equations, all right, like this one, 3x minus 4y equals 12. All right, let me go ahead and hide these other ones so we can focus on this one right here. All right, standard form is in the form ax plus by equals c, right? So a here would be 3 and b would be negative 4. In standard form, we focus on the two intercepts, the y-intercept and then the x-intercept. All right, again, for every y-intercept, x is equal to 0. So what do? We put in 0 for x, and then we get negative 4y equals 12. All right, so y is negative 3. And to find the x-intercept, we put in 0 for y, and we get we get 3x equals 12, so x is 4, and then we make the line through them. So the way to graph it in standard form is to find two of the points that make the equation true, the x and the y-intercept, and we draw a line through them to get all of the rest of the solutions. Every point on that green line will make it true. All right, let's do one more in standard form. What about negative 2x, all right, minus 4 is equal to 8, say. Whoops, negative 2x minus 4y, excuse me. I missed that right there. Okay, so again, we're going to focus on these intercepts right here, that one there and that one there. So when you want to find the y-intercept, you put in 0 for x. So if I go to this equation, if I put in 0 for x, that first part is gone. Negative 4y equals 8, so y is negative 2. And to find the x-intercept, you put in 0 for y. So you put in 0 for y, you get negative 2x equals 8, so y is negative 4. Again, that's 2 points that make it true. Draw the line through them, and all the rest are true. Now you will notice all of these equations we graphed were diagonal. They went at an angle, right? But sometimes a line can be completely vertical or completely horizontal. All right, so let me go ahead and hide all of these. Now, what would a completely horizontal line look like? What would a completely horizontal line look like? Well, let me just show you. What if I type in y equals 3? All right, you'll notice that line y equals 3 goes straight across. Can we change the color on that to a different color, because black kind of fits in too well? Okay, so y equals 3, it goes straight across horizontally. Now, why does that happen? All right, because the slope is 0. All right, remember y equals mx plus b. So this is actually just a special case of y equals mx plus b, where m is 0, so that x part goes away, right? So if I wanted to here, I can just slide this. See how I'm just sliding the y values up and down, and it's just staying completely horizontal. Isn't that cool? All right, so that right there would be y equals negative 2. Right there, y is equal to 0. There's y is equal to 1, if I could get it exactly. All right, I'm not, but no worries. You see how it works. So you simply have the y-intercept, and all of the y values are the same as the y-intercept. So a horizontal line, pretty darn simple. It's just y equals whatever that value is right there where it crosses the y-axis. All right, what about a vertical line? Well, if a horizontal line is y equals, how about if a vertical line is x equals? All right, what about if we do x equals 3? X equals 3. Now, you'll notice now here is that vertical line. It's a vertical line going through. I'm going to go ahead and hide this one now. All right, a vertical line going through 3. Just like before, though, we can move this around, and you see that point down on the x-axis moving? Well, that simply tells you the value that x is. Because it goes straight up and down, the x value stays the same. No matter where I am on that line, x always equals -5. All right, this is a special case of standard form, all right, where the y doesn't matter. The y can be anything. Now, the slope of this one is what is tricky. We call this slope undefined. So this is a kind of an unusual one, and later on when you study functions, you'll learn that this is not a function right there. Okay, so there's x equals 1, there's x equals 2, there's x equals 3, and so on. See how that works? So a vertical line is simply x equals, and whatever that value is, where it crosses the x-axis. There's x equals -6. There's x equals -8 over there. All right, and again, the y equals, that's my horizontal line. The x equals, that's my vertical line. That's all there is to it. And again, the slope of a horizontal line is 0, and the slope of a vertical line is undefined. All right, it really is that simple. Okay, and I hope that was simple for you. If not, feel free to ask for more help from Mr. Reeves at any time. Have a great day. Until next time.